So we're going to finish up the note sheet from yesterday. We're going to do 2 with dividing, then 2 more with addition and subtraction, 2 more with multiplication and division. Then we're going to use the graphing calculators, and we will be done for today. And that'll be the end of this part of the section. So the first thing we're going to look at is division. F divided by G of x. Well, this here is the same as f of x divided by g of x. So it's just another way to write it. F divided by g of x is the same as f of x divided by g of x. Now for us here, f of x is 6x. G of x is x to the 3/4. So we have 6x divided by x to the 3/4. Now when we divide this here, since there's nothing being divided with 6, it's just by itself, we'll have 6. Now if we do have some type of division, if it was 6 over 14, we can simplify that as a fraction and leave it out front. Now because the variables are being divided, we would subtract the exponents. 6 times x to the 1 minus 3/4, and we would subtract because we are dividing. When we divide like bases, we subtract their exponents. And 1 minus 3/4, we're going to have fourths, and we could do that in the calculator. Or we can do it by hand, either one, and it would give us 1/4. Any questions on any of this here so far? Now we're going to have to look at the domain. Now what would the domain for this here be? Yes. But we actually just say greater than. Because of the fact that we're dividing, the denominator or the bottom or what we're dividing by cannot be 0. So even though what we finished up with doesn't have anything in the denominator, we're not dividing by anything, but because we divided from the beginning, we cannot include 0 in this here whenever we divide. So these here, when we talk about division, x is going to be greater than 0. Or it could be, if it is all real numbers and we're dividing, it's all real numbers except for 0. We still can't divide by 0. Any questions on this here? Okay. Well, last but not least, we need to take f divided by g of 16, which for us here would be 6 times 16 to the 1/4. And again, at this point here, we can plug this into the calculator. You can do 6 times 16 to the 1/4 in the calculator, and it would give you your answer. Well, 16 to the 1/4 is 2, and 6 times 2 gives us 12. Any questions on this here? All right, let f of x be 4x and g of x be x to the 2/3. Find f divided by g of x, state the domain, and then evaluate the quotient when x is equal to 27. So the first thing we're going to do is we're going to place f of x and g of x with what they are equal to. So 4x for f of x and x to the 2/3 for g of x. So we'll divide our numbers if we need to. So here it would just be 4, because 4 over 1 is going to give us 4. Now our variables, since we have like bases, we're going to subtract the exponents. It's going to be 1 minus 2/3. And well, 1 minus 2/3 is going to give us 1/3. Now, what would the domain for this be? Well, we can talk about it here in a second. I'm going probably a little fast right now. Any questions on how we got 4 times x to the 1/3? So we're good with how we got there, yes? So what would the domain for this be here? I would agree with that, yes. But we've got even more than that. Is the reason we said x is greater than 0 and all the rest is that we actually took an even root. Now, we can take odd roots of negative numbers. It works out just fine. So the 1/3 is telling me that I have 4 times the cubed root of x, which makes it an odd root, which means the domain is actually all real numbers except what? 0. Because again, since we're talking about division, g of x, whatever makes g of x equal to 0, has to be excluded. So here the domain is all real numbers except for 0, because 0 would make the denominator be 0. Well, another way that we could write this is that x is an element of the real numbers excluding 0, the set containing 0. That's another way to write it. Any questions on this here? Any question of anything we've done so far? Okay. Now, last but not least, we need to plug 27 in for x. F divided by g of 27. So we'd have 4 times 27 to the 1/3. So 27 to the 1/3 would be 3, and 4 times 3 is 12. Any questions on any of this here? Are we good with these here? Yes? Okay. Okay. Yep. So we're going to look at another one. So if we're good with division, yes? Kind of how that looks. We're going to look back at addition because I want to show this one here with our x to the 2/3 where we have this rational exponent. Now, this here is actually what your homework is going to look like. So it's not going to be like the first ones where we did where it was just addition, did everything, it's just a multiplication or just one of the operations. They're going to give you f of x and g of x, tell you to solve, find f plus g of x, find f minus g of x, and then evaluate for a number. So you're going to have 6 answers total for each homework problem. You're going to have f plus g of x and its domain, f minus g of x and its domain. Evaluate into both. Does that make sense? So for each one, you'll have each of the three parts. So let's find f plus g of x first. Well, f of x in our case is negative 2x to the 2/3 plus g of x is 7x to the 2/3. So we're adding these together. So negative 2 times x to the 2/3 plus 7 times x to the 2/3 would be what? 5 times x to the 2/3. Because the variables are the same, we can add the coefficients, the numbers in front of them. So there's part of the answer. Now the domain would be?
Greater than or equal to all real numbers?
It is all real numbers.
What makes the domain switch around?
It is the denominator of that rational expression. Since it is 3 in the bottom, what this is really saying is that we could say that this is 5. Now, what would be the root of this variable, or this radical? 3, and then it would be squared, which makes it an odd root. Now, with odd roots, we can take a negative number as it, because it's just trying to find the number times itself an odd number of times. So like negative 2 to the 3rd is negative 8. So the cubed root of negative 8 is negative 2. So we can take the odd roots, and it gives us all real numbers. So if it is an odd root, if the bottom of the rational exponent is odd, then it's going to be all real numbers. If it's even, then we're talking about greater than a number, greater than 0. This is not going to be a big emphasis on the test, okay? Because when we take the test and you're writing it, I don't include the domain and range. I'm not as focused on that. I'm more focused on you actually able to do the operations. I include that here because I can't exclude it from the big ideas online stuff. All right. Well, we did addition. Now we're going to look at subtraction. F minus g of x is the same as f of x minus g of x, which would be negative 2x to the 2/3 minus 7x to the 2/3. And this here will give us a negative 9x to the 2/3, because again, the x to the 2/3 is the same. In both of these, the variables are the same. We can subtract the coefficients. So negative 2 minus 7 would give us negative 9. And the domain is going to be all real numbers again, because it is a cubed root. Questions on this here? It also helps that the exponent is even. Since we have an even exponent, that means whatever, if we had a negative number in the radical, it actually would come out positive. So you might think, well, if we had an even exponent and an even root, wouldn't that do the same thing? Well, no. There's x to the 2/6, even exponent, even root. Well, what is 2 divided by 6? So it works out to be an odd root, so it works there. Well, if we said x to the 2/4, well, that would reduce to 1/2. Well, that doesn't, because it's an even root. So with even and even, they would reduce. But we're not going to get into that detailed as much in this class. Okay, well, we're almost done. We just need to evaluate it for 8. So we start off with f plus g of 8. So we're going to be using 5 to the 2/3. So it'll be 5 times 8 to the 2/3. And again, at this point, you can plug that in. $36?
Wait, are we on the plus?
Yes.
Sorry.
You're good? You would get 20. Because we can do that in the calculator. Now, probably the calculator on the computer would be a little difficult with doing the 2/3, but it's still possible. And we would do the same thing with subtraction, f minus g of 8. It'd be negative 9 times 8 to the 2/3, which I think you said is negative 36. And we get that there. So we would have those two with the addition and subtraction, and our two with the x's. So 5 times x to the 2/3 and negative 9 times x to the 2/3. And our domains would be the answers that we would have for this here. Any questions on any of this here? No? Okay. Now the multiplication that we have here, written down as this one here, I want like I want to change this up a little bit. See here. Oh, looks good. I wanted to change this a little bit, especially after looking at the assignments, because I noticed that the assignments didn't have numbers, because all the ones in these examples, we had a number in the numerator and one in the denominator, so it simplified to just be in that number. I want us to be able to see this here so that when you hit these assignments on the homework, you know how this ends up working out so that you're not getting counted off because you typed it in the wrong way. I've already looked at one and they got the right answer, but because they typed it in not how the computer wanted it, it marked it wrong. So, yep, 7x to the 7/3. 7x to the 7/3. F of x times g of x. So we're going to multiply these together. Now, when we multiply them together, we'll have 11x cubed times 7x to the 7/3. And even when we did the multiplication, really we only had one number in f of x or g of x. Here we've got 2, which is fine, because we'll multiply those two numbers together. Because we'll do 11 times 7, which is 77. Like basis, so we'll add the exponents. So we'll have x to the 3 plus 7/3. So we'll add the exponents together, 3 plus 7/3, which will give us 16/3, I believe. because we would convert 3 into 9/3, because 9 divided by 3 is 3. Have like bases. And 9 plus 7 gives us 16. So we have 16/3. So our f times g of x is 77x to the 16/3. Now the domain would be what? All real numbers, because since we're talking about cubed roots, it can be all real numbers. And really, whenever you look at this here, the domain, how we figure out what it is, it's really looking at the restrictions of both functions, what values we can't plug in, and applying that there. So if we actually had a square root and a cubed root would be all real numbers. Square root has to be greater than or equal to 0. And plugging that in and considering that. So any questions on the multiplication before we move on to division? Okay. So this would be f divided by g of x, which would be f of x over g of x. So we'll have 11x to the third divided by 7x to the 7/3. So this here is the first one that we've encountered where we actually had a number in the numerator and the denominator, yes? What we can do with this here is simplify it if we can. Well, does 11 divide by 7 evenly? No, it doesn't really simplify or divide at all. So what I'm going to do is leave it as 11/7. I'm going to leave it as a fraction. Now, when we divide our x, the variables, that x, we've been putting it up in the numerator. Because when we divide like bases, we subtract the exponents and put it up top. So we could put it with the 11, or it's going to be a little bit easier, is I'm just going to put it out to the side. Because it's almost like we're multiplying it. We're multiplying this x by 11/7 out front or up top. Either one's the same way. And the exponent would be 3 minus 7/3. And that's why I wanted to show you this one here instead of one they gave us. Because the one they gave us, we wouldn't have had that division and we wouldn't have come across it. 11/7 x. And this here will be to the 2/3. Because as we said previously, 3 is the same as 9/3. So 9 minus 7 is 2. And well, the domain is going to be all real numbers. Except what? Except a 0. I still can't plug 0 into the bottom of the fraction. So any question on either one of these here? Okay. Now we do the last part, f times g of -8. Well, this here would be 77 times -8 to the 16/3. Oh. This is going to be a huge number. Because -8, the cubed root of -8 is going to be -2, but we're going to have 77 times -2 to the 16th. So what do we have?
5,046,207. There should be a There should be a 0 in between the 5 and the 4.
Okay. Okay, so 5, 0.
4, 6, 2, 7.
Okay. Yeah, I just,
There was 400.
okay, yeah. So that is the answer there. So luckily we don't have to do that by hand because that would take a while to get there. And our last part of this is f divided by g of negative 8. So this will be 11 sevenths times negative 8 to the 2 thirds. (44/7). Yep. I knew it was going to be over 7 because, 11 doesn't divide by 7. And while the cubed root of negative 8 is negative 2, and its squared would be negative 4, so we can't simplify with that 7. So it had to be there. All right, so any questions on any of this here? So are we good with this here? Yes? Okay. We ready for the next part? Yes? Perform function operations using technology. This is normally the part of the lesson where I think y'all get frustrated why I didn't show you this first. So, we're going to be using the graphing calculator. Now, the graphing calculator won't give you the f plus g of x is equal to, so like the last one, 77 times x to the 16 thirds. But it will give you the last part where we can calculate this. So, what we're going to do is we're going to hit y equals. And for us here, f of x is the square root of x. So in y1, I'm going to go second square root of x. So I'm going to put the first equation in y1. Now in the second equation, well, our other equation is the square root of 9 minus x squared. So I put the first equation, or f of x, in y1, and put g of x in y2. And once you get this typed in, we'll go second quick. So what we want to do first is we're going to do f plus g of x. Well, that's the same as f of x plus g of x, yes? So the first thing we're doing is f of x plus g of x. But our x is actually going to be 2, because we're wanting to find out f of 2 plus g of 2, because that's what it's wanting us to find, because solve these for when x is equal to 2, yes? Now this is what's interesting. Go alpha trace, alpha f4. And you should get a little menu like this here. You don't have that for the ones of you who do have the graphing calculator? Yes? Hit enter. So y1, because we want to select y1. Because that was our f of x function. Yes? Now what we'll do is we'll go parentheses 2, close parentheses. So what the calculator is seeing and what we're telling it is we wanted to take the function in y1 and evaluate it for when x is 2. Okay, let's add to it alpha, I'm going to click alpha, trace, and this time I want to go down 1 and select y2 and hit enter. And then we'll do the same thing. So what this is telling the calculator, I want you to plug 2 in for y1 and add to it the value of when we plug 2 in for y2. Hit enter. That's the value for f plus g of x. Questions on this here?
Is this, it's not asking for the first part of it. That's the only part it's asking for.
Yeah, they're just asking us to find that. Now, finding f minus g of x when x is 2 is actually a little bit easier than what we just did. And if I go back up and select y sub 1 times 2 plus y sub 2, parentheses 2, I can bring it back down and scroll over and change the addition sign to minus, hit enter, does it again. Because once we really type this in once, I'll step over here, we can keep recalling it. Do multiplication. Division. And that's all 4 of them. And that's all we have to do for this here. I mean, if we wanted to use the calculator for it. Now, let's see here. I think we had 11x to the third. And then we had, I think I'm flipping those. Oh yeah, then we had 7x to the 7 divided by 3. Because that was our 2 functions. So I can quit. So we did the multiplication, and I'll end up probably having to retype this. Because we had negative 8. Parentheses, negative 8 times alpha trace, enter, parentheses, negative 8. And that's the answer we got, yes? So this makes it a little bit easier to calculate. Too far. Well, I don't like that. I want that as a fraction. We have our answer. And it'll do those there for us. Questions on these here? So we kind of see how the graphing calculator can do some of this for us. Yes? And it'll really even solve these radicals, because we saw that the other day, where we can put it in for y1 and y2 and see where they cross. The only time for radicals that's not helpful is if the solution is a decimal or a non-repeating, non-terminating decimal, and not a nice whole number.